session, which is titled Access of Scalability when Training Conversational Agents, and it will be given by Boureau, who is a research scientist at Facebook AI Research, focusing on building helpful conversational assistants and fostering stronger people orientation in AI. Before coming to Facebook, she was a postdoc in experimental psychology and neuroscience at the New York University, investigating self-control and meta-decision making. And she received her PhD also from NYU and École Normale Supérieure. So with that, I will leave it to the video, and as with the previous two talks, Ilan will be available for questions at the end. And please ask questions along the way.
Hello, my name is Boureau, and I'm a research scientist at Facebook AI Research. Today I want to talk about how scalability is at the core of our research program for conversational AI at FAIR, and how it ties together many of the directions that we have in our projects. So in order to do that, I won't really be giving much technical detail for lots of the papers that I will be mentioning, but I'm including the titles so that you can look them up if you want more specifics. So when we say scalability, it can really mean different things. And one thing that is important to us is that that is at the core of why we do learning, as opposed to writing everything down and trying to have a system that has been entirely designed by hand. So in this talk, I will go over the different dimensions along which we can see this idea of making training possible and making it more automatable, so that we can design systems that work better and better without having to put all the pieces in place by hand, and instead letting optimization or automation do the work for us. Many of the ideas that I will be talking about today have been summarized in an overview paper that we put on arXiv earlier this year, that I invite you to look at also, because it contains a lot of the guiding principles for our research programs, and was written by a bunch of people at FAIR. So I will be going over a lot of the ideas contained in the paper, and also some that are absolutely not in the paper, but are with the same spirit, let's say. What comes to mind when we talk about scaling? I would say most often it's the idea of bigger models that are more demanding in terms of compute, that have a lot more parameters with this exponential growth that I'm going to talk about, and that also require more data to be trained. And we also expect that the models are capable of doing more and more tasks. So the first, I would say, more obvious dimension is the idea of getting bigger. But there's another aspect to that, is that for all these new models, new outputs that we're producing, we need to evaluate them in a way that is also scalable, so that is reasonably cheap and automated. So I will go a bit over that as well. And if we try to synthesize these two broad directions of having models that are capable of doing more tasks and being evaluated in a way that's efficient, we land on this principle of online training and continual learning, where the models can adapt to a changing environment and whatever happens in the future, without having to be retrained from scratch every time, because that is not really scalable. Finally, I will say a few words about how perhaps scaling research itself is our best chance to get to the goal of better conversational AI as a community. So how we can help others build on the work that we all do, and make collaborations easier. Bigger models. I really like this graph that comes from the Distelbert paper from Hugging Face. It shows the size of popular models from 2018 to the end of 2019, and you see how models have grown from about 100 million parameters to all the way to 8.3 billion parameters with Megatron from NVIDIA. Of course, things didn't stop here, and Microsoft updated that graph with their own Turing NLG 17 billion parameter model. This is still going on. We can still increase and have bigger models as scaling and parallel training improves. Of course, the question is, do these models actually perform better for the metrics that we are interested in? This table is from a paper by Boyd and colleagues, 2020, that adapts the Megatron architecture for dialogue, and there's a bunch of other cool things in that paper. But what I want to focus on in this slide is the effect of scaling. As you can see in this table, when you scale up the model from 100 million parameters to 8.3 billion parameters on that given task, the perplexity dramatically decreases. And another question then is, does this decrease in perplexity lead to better performance in terms of metrics that humans care more about? And this nice plot from the Mina paper, Adiwardena and colleagues 2020, suggests that yes, perplexity is reasonably predictive of some quality human metrics. In this plot, what they do is each blue dot corresponds to a different model, a different version of the Mina model. And the perplexity score on that same task is a good predictor and very highly correlated with the SSA score, which is a human metric that captures sensibleness and specificity, so a better sense of the quality of the model than just mere perplexity. The plot that I'm showing now is our own work at FAIR. So this is a paper that we published earlier this year, Recipes for Building an Open Domain Chatbot, where we test lots of different ways to try and improve over a model to make it good at chatting about everything. And what we see in this plot is that when comparing a 2.7 billion parameter model and a 9.4 billion parameter model, we indeed find that we can reach lower perplexity when using the model that has more parameters. They were both trained for the same number of gradient steps and on the same training data, which is 1.5 billion training examples from the Reddit dataset collected and released on pushshift.io through July 2019. I want to quickly mention some of the ways these big models have been trained in our papers. These are tricks that were used in other papers, the Megatron papers and others, that use several styles of parallelism to make it possible to train this billion parameter model. So in this case, we used Megatron language model style model parallelism, which slices the layers vertically for training, and mixed precision training with memory efficient FP16 training in the FAIR-seq library. And now when we look at what happens with quality evaluation by humans, we actually see a picture that is a bit different. So I'm not going to walk over all the results in this table, which is in our paper, but I want to draw your attention to two lines in particular. The rows that I have circled in red here are of the same model, but either with 2.7 billion parameters or 9.4 billion parameters, which, as we saw in the previous slide, the 9.4 billion parameters had lower perplexity when training. So the results here are showing how many times the model was preferred to a human conversationalist in fully realized conversations. I will talk more about how we do these evaluations later in the talk, but suffice it to say that higher is better in the model column, which, given that they add up to 100, means having the human winning less often. And what we see here is that despite the 9.4 billion parameter model having lower perplexity, it does not win more often against the human. If anything, it wins less often. You get a 45% win rate as opposed to 49% win rate for the generative model that has 2.7 billion parameters. So here what we see is that the increased performance in terms of perplexity did not translate as increased performance for an engagedness rating, where the question we ask humans is what model or what interlocutor they would prefer to talk to for a long conversation. I will go more later over other aspects of how perplexity, while very useful and predictive, is not always enough to capture some differences in evaluation by humans, and that decoding, in particular, how decoding aspects matter. But first, I want to mention that the models that I have compared on the previous slides are fine-tuned, and that this indeed is another very important aspect of the idea of scaling training. So as we saw, we are now dealing with architectures that are several billions of parameters big, and that requires billions of examples to train. If we want those architectures to talk in a certain way and display certain conversational skills, it would not really be tractable to collect an entire full data set of billions of examples for each skills that we want our models to be able to express. So instead, we use the same ideas has proven very effective across NLP, which is have this wide scale pre-training over a kind of more general data set from the wild, in that case Reddit, because we're doing conversation, and then fine-tune it on a much smaller scale data set that shows the type of output that we want this model to be able to give. In this case, I'm briefly going to go over 4 types of skills that our different data sets that we released are focusing on. And I'm going at it in a kind of chronological way. So one of the first data set that our team released is the Persona Chat / Conv AI2 dataset, where conversation partners are given a persona, which is a set of little items that describe some of their tastes and hobbies, and they use that in the conversation as talking points. So this is a way to provide the models with some speaking material that would be what you might want to see in a nice casual chat between people who are getting to know each other. We also wanted our models to display some empathy. If you recall that the main models were trained, the pre-training of these models was done using data from Reddit. This is what happens on the internet, is that you have all kinds of people posting things, and they are not always the best example of sensitive responding and displaying empathy and kindness. So if we want our models to be more understanding of what the other person is going through, we have to explicitly ask people to show these qualities and model them for us. So we collected a crowdsourced dataset in that paper, Toward Empathetic Open Domain Conversation Models, a new benchmarking dataset at ACL, where we released a benchmark called Empathetic Dialogues that collects conversations between people who are asked to be empathetic and acknowledge the emotion of the other person, respond in a way that shows that they understand it and pays attention to it. Another important aspect of the conversational agent that we would like to develop is that it should be able to use some knowledge. So if it's given access to a wide body of knowledge like Wikipedia, is it able to use that knowledge to inject it into the conversation? So this is the focus of the work Wizard of Wikipedia. And we added that as part of our set of fine-tuning data sets that we want our model to be able to mimic in terms of skills. And finally, a paper that we released earlier in this year, early 2020, is the blended skill talk dataset that attempts to blend all the skills by weaving them into a cohesive conversation where different skills, displaying knowledge, empathy, personality, are going to appear in a blended way in a single conversation. So this is the blended skill talk dataset. And in that paper, we show how we can combine these different tasks into a single one and result in models that are rated better by humans. So this this set of data sets that we collectively call BST, because the blended skill talk is a blend of the 3 separate single skill data set plus the one that tries to merge all of them. These BST data sets are the ones that we used to fine-tune our pre-trained model in that recipes paper that I mentioned earlier. And then when we compare the performance as evaluated by humans in terms of engagingness between the pre-trained model that was simply trained on push-shift Reddit and the fine-tuned model that was trained on these 4 tasks that I mentioned, displaying 3 different skills and the blend of those skills, what our results show is that humans largely prefer the model that has been fine-tuned, 61 to 39. This is a significant difference. So the model that was first pre-trained but then fine-tuned to on these much smaller data sets to gain these skills, if you will, is performing much better. However, this way of fine-tuning requires that we have a single model that is, in a way, going to decide what skill to display as it deems appropriate. We want it to display personality, empathy, knowledge all together, and we let the model decide when each of them is appropriate. What if we instead want to be able to have a single model and a single architecture that is capable of doing lots of different output modes, showing a certain tone or modality or a different task in a way, or certain different characteristics so that they can be more personalized depending on the person that the model is talking to. And this is another way of scaling training where instead of, again, training from scratch with one model per task that you might want to be doing, you have a single architecture that shares really most of the parameters of the model, but then there's some mechanism to control at inference time what type of output you're going to get. So instead of having to have one huge model per task, you're going to have a single architecture with this inference time switch that specifies what type of output you want. There are several previous works that have worked on this idea. So in particular, there's this paper by ABC and colleagues about what makes a good conversation. So if, for example, looking at factors such as length, number of questions, these kind of things, and showing that they really change how humans rate the models. And then there's the control paper from Keskar and colleagues in 2019 that shows how, this is not for dialogue, but it shows that how when you have a language model, you can learn these control tokens that really change what output you're going to get for the same input, depending on what control token you ask the model to use. And in the conversation space, there's this very recent paper from last month, I think, by Madoto and colleagues, plug and play conversational models, which builds on the plug and play language model paper to adapt it to the conversational space, and shows that you can indeed get this inference time control in order to, how can I say, to have a single model do more things without having to have one model per type of output that you would want. So we have work in this space as well. The paper I'm talking about on this slide is one we released on arXiv last month by Eric Smith and colleagues. In that paper, we compared different techniques that had been proposed for inference time control and see how suited they are for large-scale conversational AI models of billions of parameters. What we see is that there's one method that works better than the others and is more scalable, which consists in adding the control token at training time and training on that modified context. The paper also shows lots of techniques to get this to work and apply when you only have a small subset of labels, how to scale that labeling up by relabeling lots of much wider data sets with a classifier. And we show in that paper how this works to generate this type of style control outputs. It works quite well. But now I want to go back to this idea of scaling evaluation. So you recall this plot I showed earlier from the Mina paper that was showing a nice correlation between perplexity and human quality measures. So as I mentioned in a slide before, in our recipes paper, we asked humans to rate engagingness of model, and we saw that perplexity was not always predictive. Another thing that we study in the paper is that the different decoding methods are going to lead to different engagingness scores. This, again, cannot be captured by perplexity, which is agnostic to decoding. So we still seem to need human evaluation, which doesn't scale so well. So how can we make it a bit less bad? If we're still going to use humans, how to make the rating as efficient as possible? The methods we used in that paper for evaluating with humans is building on that acute eval paper from Margaret Lee and colleagues from our team that is leveraging full conversation, comparing full conversations and asking people to do A/B comparisons between them. And they show how this is more robust in terms of rating, so you can get better rating for cheaper. And you can reuse the conversations because it's not an interactive evaluation, so you don't need to have people chatting with the bot every time you want ratings. We also, the paper also shows that you can use self-chat for cheaper evaluation, and that this gives you some prediction of which models are going to perform better. Another thing I want to mention is that if indeed our benchmarks are going to be repeatedly broken, it's not scalable to just start new ones every time. And instead, it would be good for the community to move towards a more an idea of evolving living benchmarks that evolve as models adapt. So that's the idea behind Dynabench, which is a framework for automating this human-in-the-loop framework of repeated adversarial training. I invite you to go to the website for Dynabench to learn more about this and perhaps try the task yourself. If you scan the QR code, it will take you there. This is a framework proposed by Dawi Kila and colleagues at FAIR for replacing static benchmarks by dynamic benchmarks that will automatically evolve as the models get better, again, to scale up our research efforts in a more automated way. This leads us to the theme of continual learning. Continual learning is important if our models are going to be deployed in changing environments. And a very good example of that right now is conversational models trained before 2020 would know nothing about COVID, for example, whereas now lots of conversations revolve around this. So be it only to be able to capture current events, you need models to be able to learn continually. So that's one aspect of this. Another aspect of it is that the models should be able to adapt to whoever they're talking to. People can change the way they talk. People can also, importantly, give feedback. So if I talk to somebody and they say something bad, I might say, oh, you know what you said, it really was offensive. It would be much better for our models to be able to understand its feedback and learn from it. And that way we can hopefully avoid the well-known fate of Tay, Microsoft's bot that had a very short life on Twitter before being removed because it was displaying a lot of toxic and offensive language. So if we are going to have some continual learning, we need to have a public-facing agent that is engaging so that people talk to it, and that gives us an automated metric of engagement, because if people stop talking to it, it indicates that perhaps it's not so good. So that's also one aspect of the evaluation, that we get these behavioral metrics. That agent should be continually learning so that it can adapt to fresh data. And it should be well behaved, treat people well, and learn from their feedback. People in our team have worked on this topic. So an example paper from Hancock and colleagues in 2019 is learning from dialogue after deployment feed yourself chatbot, where the bot is trained to learn from feedback provided by a human partner and improve based on this. And more recently, I think just this month, Shuster and colleagues released this paper on their framework Lite, which is a text-based game that has been deployed on the internet, and people are talking to it and creating all this extra data set. And as you can see from these plots on the right, what this plot is the cost on the x-axis and the improvement in some metrics, which is here hit at 1 on the y-axis, and the red curve, which is a much better return over cost, is what you get when you use that wildly collected data to train your bots. So this is a way to do deployed continual learning that shows that it makes training a lot more scalable, because you don't need to collect all these data sets manually, and instead you can let the bot collect its own data set by just running and having people talk to it. Another effort in this direction that we haven't yet published a paper on, but that you can actually already talk with, is Captain Kiwi. So if you scan that QR code or go to this URL, you can talk to that bot on Messenger. This is a bot that can talk about images and chat with you. It's a retrieval model. And it has a slight gamification to encourage people to talk with it. So once these models are deployed, a big part of our effort is also to make them better behaved. I already mentioned empathy earlier. Another big part of our efforts concerns safety, making sure the models don't say offensive stuff or toxic stuff or display too much bias. We just released this month a paper called Recipes for Safety in Open Domain Chatbots on arXiv. And this paper by Jingsu and colleagues is in a way an update over the paper by Dainan and colleagues from 2019 that was performing iterative training of classifiers for toxicity, again with this idea that to scale, training needs to be able to adapt to new adversaries that are going to break whatever system you have in place. It needs to adapt, and you can't always start from scratch because it needs to adapt to an environment. It's a type of like arms race between blocking and new angles of attack. So in this new paper, we look at several strategies, and we ask a crowdsourced worker to do adversarial breaking of the model, where they try to goad the model into saying bad stuff. And in the paper, we go over several strategies like non sequiturs that are baked into the model. The model is trained to change the subject when something bad happens or something bad comes up. And we show different how well the different techniques perform. Another aspect that's important for us as a community, and I don't mean just us, Facebook FAIR, but I mean all the researchers work on conversational AI, is how we can scale innovation and how we build upon the work of each other. For that, we believe an important aspect is open sourcing as much as we can, both in terms of the code, the data sets, the tasks. For that, we use our Parlay framework, and we encourage everybody to build on that. We try to make it as easy as possible, because this can accelerate research by sharing frameworks, so that there all this overhead of setting up about these kind of things that goes away. I want to end with the amount of challenges that we still have to deal with, which is probably why we will keep needing more tasks, more bigger models, more data, is there's so much that our models still can't do. They're not good at reasoning. Safety is really hard, and the models are still failing at this. The personality of our models is inconsistent, and it changes, and it doesn't really learn anything about the partners. Our models show repetition, hallucination, lack of common sense, no deep understanding, and evaluation that's really good is still expensive and not that scalable. So these are all directions for which we will need to apply all these ideas of continual learning and fine-tuning, leveraging tasks, commonalities in the future. That's what I had for today. Thank you so much for your attention. And again, here's our kind of overview paper for the guiding principles of many research projects in our team.
Great. Thank you very much, Ilan, for a great talk. As we wait for others to ask questions, I have one or two of my own. One thing I was thinking in the context of lifelong learning, have you looked at combining that with, let's say, personalization? So you have an agent that learns about the user that it interacts with, sort of more specifically, and that way it could maybe be customized to run on the device? And how do you deal with the interplay between having enough information to learn and to do a good job while still being very privacy focused?
Yeah, that's a great question. We indeed have some people, not me specifically, but some people on the team are indeed working about this, like working on this, like how to expand personal knowledge about your person, so that if you're talking to somebody, you kind of keep an expanding persona on who they are. And the way I can view this, so at the moment, these are very like game-y chatbots, because people don't really talk about serious stuff with them. It's more like to play. But the way I would view this from a privacy point of view is that all these things that are more like inference time that you can put in the context of your conversations, let's say what you remembered from the person stays in the context, it really doesn't have to be shared. It can just stay, let's say, on your device when you're talking to somebody. You can think, okay, that's where this tiny bit of information is being kept. And it never, and we don't train on that. We don't need to train on that at all, because it's inference time stuff. So that's why I like this all this work on inference time control, because this is stuff that requires no training, so it can really stay with the person and not be shared with other people, and that's good for privacy.
So Albert has a question as well. He's asking, how do you think we should solve our chicken and egg problem? We need large real data to build great agents, great bots, but at the same time, we cannot expose half-baked, unsafe agents to people.
Well, so that's indeed a tricky question. The thing is, we already have bots that are pretty good. And so to me, the most important thing is to frame them really correctly and be very transparent about their limitations. And so tell people upfront, because there's lots of people who have a lot of appetite for talking to bots, even despite their current limitations. An example I saw very recently is with some of the replica bots, which are, they have this whole thing where you can have a relationship with that replica bot. And some people take it really, really seriously, like they're exclusive with their replica bot and they're not dating humans because they're dating their bot, which is weird, but that's real. And so one person was very upset because the replica bot actually said that he was doing stuff with other replicas, and the person said, oh, I thought we were being exclusive. So you have all these things that happen that are very tricky to navigate. And so I think the important point when these type of things happen is to really make sure we tell our users upfront, if you chat with this bot, some things may happen. They may say some random stuff. So remember, this is a bot. It has lots of limitations, and chat with it at your own risk, because we are trying to work on it. But so I think for me, it's more about communication and transparency and making sure that we communicate what the limitations are, so that we can bootstrap and make them better.
I'm thinking that that's an interesting point that you made, thinking of the morning talk from, I think, Tom Ye, where he was mentioning that if something goes wrong, it's to some extent we have some shared blame, and so the messaging that you just mentioned is an important part of that, perhaps in trying to set the expectations as to the limitations of the technology.
Yeah, and also something I want to add to this is that the optimal trade-off, in a way, between the level of safety we would want and robustness in a bot and functionality will really depend on what the bot is for. So if it's a bot that's kind of a game and you play with it and it's not supposed to do anything useful, then it's a lot less critical than an actual application that people would use to actually make decisions or drive their car or do stuff where they have an expectation that you will perform certain things. So I think, again, these things need to be parameterized according to each specific use case. If it's something for research, and we tell people this is for a research bot, it's going to say stupid things, it's going to hallucinate facts, don't follow its advice. It's not the same as saying, okay, I'm putting that in a product and it's going to give you some questions about, let's say, medical questions you would have. That's going to be a much higher threshold.
Makes sense. So we're 5 minutes over. So if you have any other questions for Ilan, please post them in the stage chat, and hopefully she will stay a little bit longer with us and answer them, even though it's pretty late on the East Coast, I think, already on a Friday. So thank you, all the speakers, and we will take a 10-minute break at this point and then go back to the panel, which will
Thank
be
you very
in a
much.
different stage. Thank
Bye.
you. Bye.